Welcome to this video on instruction and instruction sequencing in computer systems. Every task a computer performs is broken down into a series of instructions that need to be executed in a specific order. In this video, we will explore how instructions are structured and how they are sequenced to ensure smooth and efficient operation within a computer. What is an instruction? An instruction is a command given to the microprocessor to perform a specific task on specific data. For example, add AX BX, explaining how it tells the processor to add the contents of the register BX to AX. Instruction set, the complete collection of instructions a microprocessor can execute is called an instruction set. For example, x86, ARM have their own unique instruction sets. Mention that an instruction set defines the capability of the processor, such as arithmetic operations, data transfer, and control instructions. Instruction sequencing is the order in which the instruction in a program are carried out. Discuss the importance of the following correct sequence for ensuring the program execute as intended, and also mention how the program counter plays a key role in maintaining the order of instructions. There are four types of operations a computer must perform: data transfer between memory and processor registers. It describes how instructions like move, load, and store transfer data between memory locations and the processor's internal registers. Arithmetic and logical operations explain that arithmetic operations, for example, addition, subtraction, and logical operations, for example, and or allow the computer to process the data. Program sequencing and control discuss how control flow instructions like jump, call, and return alter the normal sequence of instruction execution. It also mentions how conditional instructions enable decision making in programs. And finally, input and output transfer. It explains how input output instruction manage data transfer between the processor and external devices, for example, keyboard display. Instructions like in and out perform input output transfers. Data transfer is how a computer moves information between its registers, memory, and input output devices. We use symbolic names to represent memory locations, processor registers, and input output register. For example, LOC place and mem represent memory addresses. R1, R2 are the processor registers. Data in, data out in are the input output registers. Square brackets are used to show the contents of a location. For example, LOC within the square means the value stored in the memory location LOC. In a data transfer operation, the source is where the data comes from and the destination is where it goes. The source does not change, but the destination is overwritten. Example of data transfer. The first one shows the move the data from the memory location to register R1. The second one move the data from the register R2 to memory. And the third one is showing move the data from the register R1 to input output register data out. Data transfer instructions. It is also called as copy instructions. It is used to transfer data from one place to another, either between registers, memory, or other components. In the 8086 microprocessor, these operations move data but do not change the source. The move instruction copies data from the source to destination. The load accumulator instruction loads the accumulator with the data from the memory location. The store accumulator instruction stores the contents of the accumulator into a memory location. The push instruction stores a register pair onto the stack. The pop instruction retrieves data from the stack into a register pair. The arithmetic and logic unit in the microprocessor handles all data processing tasks. It performs operations in three categories: arithmetic instructions, logical and bit manipulation instructions, and shift instructions. Arithmetic operations are fundamental to processing data in a microprocessor. The 8086 microprocessor includes several instructions to perform this operation efficiently. Key arithmetic instructions in 8086 are increment. The increment instruction increments a value by 1. For example, increment AX increases the value in the register AX by 1. Decrement. The decrement instruction decreases a value by 1. For example, decrement Bx decreases the value in a register Bx by 1. Add add instruction performs the addition of two values. For example, add Cx dx adds the value in register dx to the value in register Cx. Add with the carry. The add with the carry instruction adds two values along with the carry bit from a previous operation. For example, add with the carry ax, bx adds the values in registers ax and bx, including any carry from a previous operation. Multiplication. The multiplication instruction performs multiplication of two values. Example, multiplication Cx multiplies the values in register Cx by the value in the accumulator Al or Ax. Logical operations are crucial for performing bit-level manipulations and comparisons in a microprocessor. The 8086 microprocessor provides several instructions for this operation. Key logical instructions in 8086 are and the AND instruction performs a bitwise AND operation between two values. For example, AND AX, BX performs a bitwise AND between registers AX and BX, storing the result in AX. The OR instruction performs a bitwise OR operation between two values. For example, OR AX, BX performs a bitwise OR between registers AX and BX, storing the result in AX. The NOT instruction inverts each bit of a byte or word. For example, NOT AX inverts all bits in register AX, effectively performing a bitwise NOT. XOR instruction performs an exclusive OR operation over each bit. For example, XOR AX, BX performs a bitwise XOR between register AX and BX, storing the result in AX. Shift and rotate operations modify the bit arrangement within a register. These operations are useful for tasks such as arithmetic calculation and bit manipulations. Key shift and rotate instruction in 8086 are shift right. The shift right instructions shift bits towards the right, filling the most significant bits with zeros. For example, shift right AX, 1 shifts the bits in register AX one position to the right with a 0 in the MSB. Rotate left. The rotate left instructions rotates bits towards the left, moving the most significant bit to the least significant bit and to the carry flag. For example, rotate left AX, 1 rotates the bits in register AX one position to the left. Rotate carry left. Rotate carry left instruction rotates bits towards the left, moving the MSB to carry flag and the carry flag to the LSB. For example, rotate carry left AX, 1 rotates the bits in register AX one position to the left using the carry flag. Thank you for watching.